Hello, my name is Amber Bullen, and my presentation is about wrist flexor and extensor muscle recruitment during different contractions. Motor units are groupings of muscle fibers controlled by a single motor neuron. The size principle states that smaller motor neurons are recruited before larger ones, and more motor units are recruited when demand on the muscle increases. There are three types of contraction: concentric, isometric, and eccentric. And we know that of these contractions, eccentric contraction produces the most force. However, we know that muscle force does not equate to the amount of activation of that muscle, so what we wanted to find out was, with wrist flexors and extensors, which type of contraction sees greatest activation. We also wanted to know if there were differences in activation between flexors and extensors. We hypothesized that %MVC would be higher in eccentric conditions than concentric, and that flexors would exhibit greater %MVC than extensors. Surface electrodes were placed on the muscle bellies of the wrist flexors and extensors of the dominant arm. Maximum voluntary contraction was determined by the peak amplitude experienced during a resisted contraction. The subjects sat with their arms relaxed, resting on a table and in 90 degrees of flexion. We used a 5-pound dumbbell to provide resistance. For isometric conditions, participants were asked to hold the weight for 10 seconds. For concentric conditions, participants started at a max flexion for extensors and a max extension for flexors and moved through the max range of motion in 5 seconds. It was the same for extensors, but instead they started at different points. Mean %MVC and standard deviation was calculated. Looking at our graph here, flexors being yellow and extensors being blue, we found that the greatest %MVC was shown to be with concentric contraction, and that extensors showed a greater %MVC in all conditions. So this shows that results did not support our hypothesis. There are a few explanations for this. At the time, we were not aware that it is established that greater motor neuron activation is necessary for concentric contraction. This is because passive structures such as tendons or titin provide much of the force production in eccentric contraction, lending to less recruitment or activation of the muscle needed. Additionally, a study by Liebert et al. Found that wrist extensors have less cross-sectional area than flexors, which suggests that they are less able to produce force. Bringing that back into terms of motor unit activation, this could mean that the smallest motor units of the extensors were not sufficient to handle the demand placed on them, so more motor units were recruited. Clinical relevance to our studies include the fact that injury to passive structures will likely have a great impact on force production and eccentric contraction. Additionally, damage to neurons to forearm motor units will require us to prescribe exercise creatively.